Today we're going to talk a little bit about function notation, some of the function operations, and evaluating functions. You should know function notation by now, at least what f of x is, and know that there are other ways to write that function notation like g of x or h of x or so on. Evaluating functions comes from when you have a function, say f of x equals 4x plus 10, and it asks us to evaluate f of 2. Taking a look at the two function notations, f of x and f of 2, doesn't it make sense that that is asking you to replace or substitute 2 everywhere you used to have an x? That's exactly what it's asking us to do. So here we have some function evaluations to do. Number 1 says f of 5. I have 4 different functions up here, and only one of them is called function f. So this is asking us to take function f and substitute 5 in for x. That's going to look like 3 times 5 minus 1. And then of course we use order of operations to multiply it out. We get 15 minus 1, that equals 14. So I can say that f of 5 equals 14. I substitute 5 in for x and evaluate. Number 2 asks us to use function h and to substitute 3 in for every x. So I get 3 squared plus 2 times 3, and then of course we use order of operations to evaluate. 3 squared is 9, 2 times 3 is 6. It's asking us to add 9 and 6, which gives us a total of 15. So h of 3 equals 15. Be really careful to pay attention to order of operations when you're evaluating functions. Number 3 says to use function g and to replace x with -4. -4 plus 7 equals 3, so g of -4 equals 3. Number 4 asks us to use function j. It's very specific about which function to use. Replacing 2 gives me 2 squared plus 5. That equals 4 plus 5, which adds to 9. So j of 2 equals 9. Now, down on numbers 5 and 6, it asks us to do a couple of function operations. It's asking us to add 2 evaluated functions together on number 5 and to subtract function j of 2 from function f of 5. We've actually already evaluated the functions in question, and that's what needs to be done first. I need to know what g of -4 is and what h of 3 is before I can add them together. So when you see function operations this way, evaluate the 2 functions first. Then you can add them together. We already know that g of -4 is 3. And we already know that h of 3 is 15. So this is asking us to add 3 plus 15, and of course we get 18. So g of -4, when added to h of 3, is equal to 18. Again, don't forget to evaluate the functions first. Number 6 is asking us to use functions f and j. We already know that f of 5 is 14, and we know that j of 2 is 9. So 14 minus 9 leaves us with a total of 5. f of 5 subtracting j of 2 equals 5. Sometimes you'll have a function and you'll be given a domain, and you're asked to find the range. In order to find our range, and remember range comes from the y values of the function, we have to use the given x values or domain of the function and evaluate at each point. So we're going to take just a second and evaluate our function at each element in our domain. First with -2, and I get 4 minus 4, or adding -4, that equals 0. So f of -2 is 0. I do the same thing with the second element in my domain, which is 0. I get 0 plus 0, which again is 0. f of 2 asks me to substitute 2 in for x. I get 4 plus 4, which is 8. And finally, f of 5 gives me 25 plus 10, which is a total of 35. Now I've evaluated my function for every value in the domain. Every outcome, the 0, 0, 8, and 35, are now my y values, or my function values, that belong in the range. I don't need to write 0 twice when I'm writing range. I can just say I have zeros, I have 8, and 35. And that's one way to find the range if you're given the domain. Again, we took each number in the domain, we plugged it into the original function for x, or substituted it in for x, evaluated, and then our outcomes were the elements in our range. Now let's talk about how to evaluating a function using a graph, and this actually goes really quickly. Here I have a graph. I don't necessarily know the equation for my function, but I can still evaluate the function. Let's say we're asked to evaluate f of 2, only given the graph. Remember, 2 is an x value, so I need to look on my graph where x is 2. When I find the point on the line with an x value of 2, I find the point 2, 4. 4, or the y value, is my function evaluation. That's my function value when x is 2. So f of 2 is 4. How about f of -2? The point that has an x value of -2 is -2, 2. So when I evaluate f of -2, I get the function value of +2. Remember, what's plugged in is x, and our outcome is y. f of 6, since I have the point 6, 6 on my graph, is going to equal 6. And that's one way to evaluate a function using a graph. One more, f of 4 is going to be what value? That's going to be 5. Awesome. Now let's say I'm given 2 different functions, and it's asking me to find f of x plus g of x, but it does not give me x values which I can evaluate the functions for. What do you think it's asking us to do? It's literally asking us to take the 2 functions, 2x plus 3, and add it to 8x plus 10. All I need to do is combine like terms. 2x plus 8x leaves me with 10x, and 3 plus 10 gives me a positive 13. My function operation gives me 10x plus 13. Another function operation that we're sometimes asked to do is subtraction, of course. f of x minus g of x, according to our defined functions, is asking us to take x squared minus 7 and subtract 3x plus 1. We need to be a little careful when we're asked to subtract. Remember, we're subtracting the entire function g of x, which means we're subtracting each and every term in g of x. We're not going to change the first function, of course, but in the second function, we need to remember that we're subtracting 3x, but we're also subtracting positive 1. Don't forget to distribute the subtraction sign through the second function. Now when I combine like terms, I can combine the negative 7 and negative 1 to get negative 8, and we're done operating on these two functions. One more. What if I have f of x and g of x? They're the same two functions we just used, and we're asked to add them instead. Do I need to do any distribution? No, this isn't quite like our subtraction, right? With addition, we only combine like terms. Negative 7 plus 1 are the only two like terms, and they add to negative 6. So I get x squared plus 3x minus 6. All right, I think that's enough for today. I hope you have a fantastic day, and I'll see you next time.